Hello everyone, and welcome to the 4020 R10 release webinar. We hope you had a great summer and that you're ready for the final stretch. Once again, we might go a little over time, but our teams have prepared so many exciting things that we think it's worth it. So if everyone is ready, let's go. Before we dive into the details, let's hear from the people who got their hands on R10 early. Our beta tester didn't hold back. In fact, they said that this release is a big deal. They said that it completely changed the way of working with entities. And some saw it as the beginning of deeper AI integration. Others highlighted the smarter, more nuanced triggers that solve real-world problems. And yes, even those who are still exploring the features said it is promising. This kind of feedback tells us these changes aren't just theoretical. They're already having an impact on real projects. Let's take a look at today's agenda. We will start with AI for 4D. Next, we'll move to 4D Qodly Pro. Then we'll cover development improvements, and we'll wrap up with deployment enhancements. During the session, you will see live demos so you can clearly understand how these features work in practice. Before we get started, a quick reminder, please ask your question in the Q&A section, not in the chat, and our team will be there to answer your questions. So let's jump into the first segment. Basma, over you.
Thanks, Bérengère. Hi, everyone. Let's begin with AI for 4D. In this release, we've added new capabilities that make AI integration more direct and useful in real projects. But first, let's talk about something else. Most systems today still rely on keyword search. And to be fair, it does work when the wording is consistent, when the phrasing is predictable, when everything written in the same language. In that kind of clean, structured word, it nails the match. But real data isn't that simple. We all know that. If the text says resetting password or reset password, a query for reset password won't match. If someone writes fix password, but the document says repair passwords, it get lost. Even small shifts like reset password versus password resets break it. And context, keyword search can't tell the difference between a riverbank and a financial bank. That's the gap. It sees words, not meaning. And here is how it shows up for your users. They type what makes sense to them, like reset password, and gets irrelevant or outdated results. Or worse, nothing at all. Even if the answer is buried in a PDF, a help doc, or a different format, keyword search can't reach it. And the frustrating part, the answer does exist. It just doesn't use the exact same words. Maybe it's phrased as trouble logging in, or maybe it's written in another language altogether. The intent matches, but the system can't connect the dots. What we need now is search that understands meaning. That's where vector search comes in. It doesn't rely on exact matches. You can give it text, an image description, or even a code snippet or a file. It all works. It captures your intent, what you're trying to do, the context, how and where you're asking, and the concepts, the underlying ideas behind your words. Whether that's a password reset guide, account recovery, or maybe support, you get there without needing the perfect words. So what exactly is a vector? At its core, a vector is just a list of numbers, nothing more, nothing less. Think about GPS coordinates. To locate Paris, you don't describe it with words. You give it two numbers, latitude and longitude. For example, 4889 and 2.37. That's all it takes to pinpoint Paris on a map. No keywords needed. Now, if you take those two numbers and plot them on a grid like a 2D space, you get a point that marks exactly where Paris is. That's what we mean by a 2D vector. Two numbers working together to define a position in two-dimensional space. And of course, a vector doesn't stop at two numbers. It can hold many more. Think about fruit, for example. We could describe it based on sweetness, acidity, and crispness. That give us a three-dimensional vector. Let's say an apple scores high on sweetness, low on acidity, and is quite crisp. An orange might be less sweet, more acidic, and not as crisp. The values aren't the same, but if you plot them in this three-dimensional space, apples and oranges still end up near each other because they share some traits. And in practice, vectors don't stop at three traits either. They can capture hundreds, even thousands of dimensions, each one describing a different aspects of meaning. That's what makes vectors so powerful. So now that we've seen how vector search works in practice, let's take a step back and understand how we get those vectors in the first place. You can start, like we said, with just about any type of content. That content is passed to something called an embedded model. So what exactly is a model? A model is an AI program that's been trained to recognize patterns in data. That's it. And in this case, the embedded model has been trained to recognize meaning, not just the words you type, but the intent behind them, the content they're used in, the overall idea. And it then translates that meaning into a list of numbers, a vector that represents it. Because this vector comes from the embedded model, we call it an embedding. In other words, every embedding is just a vector of numbers that captures meaning. Now, these embeddings aren't generated by 4D. They come from providers like OpenAI or Ollama, whose models are built specifically for this job. And because each provider trains their model differently, vector size and structure can vary, which means similarity results can differ even when working with the same contents. So what can you build with vectors in 4D? Semantic search is the first thing. Semantic search and that understands meaning, not just keywords. Perfect for matching user questions to the right legal clauses, HR policy, or enterprise documents. Image recognition that read visual patterns, useful for retail products market matching, identifying parts in manufacturing, or assisting diagnosis in healthcare. There is also smart recommendations that adapts to user context, ranking resumes, screening applications, or used in try again in emails with suggested responses. And last but not least, anomaly detections that learns what's normal, that alerts you when something's off. Think fraud detection, security breaches, or unexpected behavior in like IoT systems. So now that we've seen how vectors are created from text, let's talk about how 4D puts that power right at your fingertips. With 4D20 R10, you get a brand new object, 4D.vector, and it all starts with just a few lines of code. You use the 4D AI kit to call OpenAI's embedding model, just like we showed earlier, that gives you an embedding result from which you extract the actual vector. Simple, direct, and native to 4D. Once you have your vector, you're not on your own. 4D gives you built-in methods to compare vectors right out the box. The most common one is cosine similarity. That's what most systems use to measure how close two meanings are. You can also use dot products if all you care about is whether two vectors point in the same direction. And there is Euclidean distance when the real question is how far apart are they really? So yes, this is semantic math, but it's already handled for you. No external engine, no external engine, no hidden layers, and no hidden codes that you need to implement. Just you, your data, and full control, all running natively inside 4D. All right, now let's watch this demo with Vanessa, where she'll show intelligent document analysis with AI in 4D Write Pro.
In my application, I have a list of documents stored in the database, and I want to let the user search through them easily. Until now, keyword search seems like the best solution. But here's the problem. You have to type the exact word. Vector search works differently. It's based on meaning. If the meaning is close, it will find the document, even if the words are different. In my database, I have several technical notes. Let's start by entering the API key. Now I will search for notes that explain how to add a section. Here are the results, sorted from the most relevant to the list. Next, let's try with a typo. Even with the error, the AI understands my search and returns technical note about image as the top result. Let's go further. I'll run the search in German, while all my documents are in English. No problem, the documents are still sorted correctly. Now let's look at the code. First, we generate a vector from the prompt. Then we compare that vector with the vector of each document. To do this, we've used the Cosine similarity algorithm. The document with the highest score is the most relevant. And that's it. An easy, intelligent new way to search your 4D Write Pro documents.
All right, so now I take the mic to introduce a demo with Basma, showing how semantic image search works in 4D.
Hello. This demo shows semantic search with AI using 4D.vector and 4D AI Kit. Here it's with image descriptions, but the same works for any text in your application. You can enter your OpenAI key here, and if you don't, the application will prompt you when it's needed. Here is a matrix of pictures saved in the database. Let's first try a custom prompt. Let's say I type fresh leaves with water droplets, rain or dew, and click Apply Custom Prompt. The matrix updates, showing the most similar images at the top. Now let's refine it. Autumn leaves floating on water with ripples. This time, autumn leaf images appear first instead of regular leaves. The results adapt to my description. And even if my grammar is bad, the application still understands my intent. For example, if I type big water drop and green leaf look shiny. Not proper English at all, yet it still brings back the correct matches, because vectors capture meaning, not grammar. It also works across languages. If I type the same query in Japanese, the application still finds the right result, because comparison happens at the vector level independent of language. And if you don't have an OpenAI API key, you can still use predefined prompt from this list box. They're vectorized beforehand, saved in the database, so they run instantly with no AI calls. For example, let's pick a colorful and playful video game world with imaginative scenery. The application returns the most relevant descriptions immediately. You can also upload your own picture. Once uploaded, it becomes searchable just like the others. Now let's trace the code and debug the flow. When I hit Apply Custom Prompt, the calculate function runs. If both a prompt and an API key exist, the AI management class generates a vector for the prompt and returns a 4D vector. Then calculates vectors, loops through all stored description vectors, calculates similarity, and sorts results by cosine similarity in a descending order. When I hit Apply Selected Prompt, the application runs the Calculate with Selected Prompt function. No embedding step needed here. The predefined prompt is already vectorized. It just compares that stored vector against all description vectors and sorts by similarity. When I upload a picture, the vectorized image description function runs. The image is encoded as base 64 first, sent to OpenAI Vision to generate a caption and a description. Both are saved with the picture entity, then embedded into a vector. That vector is stored in the database, so the uploaded picture can now be found through semantic search. So, whether it's a custom prompt, a predefined prompt, or an uploaded picture, the workflow is the same. Vectors are generated or reused, compared and ranked by similarity. All you need is a prompt.
Yes, thank you, Basma. Very interesting. And that brings us to the final part of this session about AI, a rich hands-on demo with Mathieu.
Detecting duplicates in a database when you can compare exact values is easy. But detecting similarities between records, identifying if they are alike without being identical, that's more difficult, but it's very useful. For example, when a user creates an invoice in an ERP system for a client or adds a contact in a CRM, detecting if a similar client already exists is very helpful. When creating an incident or a ticket, is there already a similar issue or ticket in the system? It's valuable to know that. Today, we'll see how 4D and 4D AI Kit can help you provide this kind of answers, of functionalities to your users. We'll explore this through a demo which we'll make available to you. This demo, as I just mentioned, was created with 4D AI Kit. We'll start with the data part. The demo comes with a pre-filled database. But these data were generated using artificial intelligence, and I'll show you how. Here we can generate about 10 clients. We'll generate them in batches of 5. Let's click on the Generate Clients button. With this demo, we wanted to provide an easy way to visualize the model at work. This is made possible through asynchronous programming. In the AI interactions section, you can see the prompt that was used, and we see the AI model in action. We simply asked it to generate clients in JSON format, and that's what we use to populate the database. We can also work with a local provider. Here I have Ollama installed on my machine. We'll use a model like OpenChat here with Ollama. Or actually, let's use Mistral. We'll ask it to generate fewer clients, 5 clients in batches of 2, and you will see why in a moment. So we'll ask it the same question. However, the execution speed will be slower than with OpenAI. But we can see it working. Compared to OpenAI, there will be a difference in quality the data might not be of the same quality that what I got with OpenAI. But as you can see on the screen, it's still solid. We'll let it finish. What's interesting here is that none of this process involves cloud exchanges, so data confidentiality is maintained. That's an important point. But if we want both data confidentiality and performance, we can add another provider in this demo. We'll call it Llama Distant. Here we have a machine that's a bit more powerful than my local setup. So we'll simply enter the data. The demo will detect the installed models, reasoning models, and embedding models. Usually we use Nomic with Llama for embeddings. Here I can tweak the default reasoning model if I want, but it's not crucial. Now let's see how I can use this remote provider. It's remote because it's not running on my workstation, but still it is Llama and not OpenAI. Confidentiality is maintained. We'll continue using Mistral and ask it the same thing. You can see the model working much faster than before. We are down to 3.6 seconds per client. We can generate, say, 10 clients in batches of 5. And the model performs very well, very quickly. We're achieving speeds comparable to OpenAI. 1.5 seconds per client. So before we continue with the demo, let's not forget about vector calculations, in fact embeddings calculations. Generally, local Llama handles this very well. There's always some initial model loading time, both locally or remotely. But if I run it again, it will recalculate all the vectors in the database very quickly. So now I have my vectors and my clients. Let's move on to the core of this demo, the similarity search. We'll perform a similarity search with a threshold of 0.9, and here we found 82 clients in the database in just 200 milliseconds. That's quite fast. So 82 clients with similarities. Let's take a look, for example, at Eric and Nguyen. This record is close to these two other records. Why are they close? Indeed, the first name and the last name are identical, but there is a small difference, a K at the end of Eric and an accent on the E of Nguyen. Nevertheless, there's a match. The email isn't exactly the same either. fastemail.co, fastemail.org, fastmail. This is typical of errors an operator might make when entering an email address given over the phone. There's also a slight discrepancy in the phone numbers, 0291, 0292. Such duplicates would be hard to find using traditional methods and algorithms. But with vectors, you can find them easily. The lower the similarity threshold, the more discrepancies you will find. For example, if we adjust the slider to 0.7, we will find many clients, 260 with similarities. Here, the clients, they don't share much in common. A similarity of 0.7 isn't very high. If we increase to 0.94, we see Jasper Diaz here has many similar records, some with high similarity, so 0.94, but others, like Aouinat Diaz, at 0.8. Here it's quite different. What you need to understand is that the results returned by vector comparisons depend on the vectorization model you use. Additionally, it's essential to vectorize intelligently. Currently, in the demo, for simplicity, I vectorize all the data of the records, but there are other options. Let's move on to another feature now and see how we can alert the user while he's entering information about a customer that may already exist in database. So let's create a client named Eric CK Nguyen. We'll perform an initial similarity search, lowering the threshold, and we find 3 similar records, but as seen, the similarities are low. Let me show you how this evolves as we enter more data. We'll indicate that Eric lives in San Jose with an accent, and we immediately see the similarity increasing. Let's add an email, faster-mail.com. This email doesn't exist in the database. We'll just run another similarity search, and now we see a similarity of 0.89, which is quite high, even though the email is spelled entirely differently. This is another example of errors easily made by data entry operators. Let's add more information, like the postal code 95123. Assuming the postal code is entered correctly, we find now a similarity of 0.91 for this record. It's up to you to determine the right threshold to alert users based on your data. In this case, it may be helpful to show the user the top 3 matching records to warn them about potential duplicates, even though the first name doesn't exactly exist as entered, nor does the email, and San Jose was typed with an accent. This would be challenging to achieve with traditional algorithm using regex, for example. Let's look at the code, which is quite simple. You will have access to the demo anyway. We'll set a breakpoint on the relevant code section. When I click the Search Similarity button, it triggers this function. So I'll set a breakpoint here. Clicking brings us to this code, where I call a singleton vectorizer to calculate a vector. This vector is based on a string derived from the client's data. As you can see, I simply concatenate the client's known values. And this is what I vectorized. And this is stored in this vector type variable. The vector variable is now a native type in 4D. Let's delve into how this vector is obtained. Let's go. It's done by calling AIKit with an AI client using .embeddings.create and passing the value. The value here is simply the string we saw earlier. Let's inspect the vector. It's a vector of length 7 168 obtained with Ollama's nomic model. Next, I compare this vector to the existing vectors in the database, the vector we calculated earlier, of course. I obtain a similarity score using the cosine similarity operation. I compare this vector to those of the clients in the database, and here I get 0.56. My target similarity being 0.7, as I set in the UI, so I won't retain this client. Currently, I process and compare each client in the database with a for each loop. In a future 4D version, you will be able to perform this operation directly within an ORDA query, which will support vectors and similarity operations. Finally, I build a collection here, which I simply return to this UI. This presentation is almost over, and this demo comes with a few bonuses. You can directly generate a client here by selecting your provider and model, just like that. Here I've generated a client from scratch. This lets you see again through these AI interactions sections how the client was constructed. You can compare how it works with different AI providers. For example, using OpenChat, and there you go, you can compare them. Another interesting bonus feature is address formatting. Imagine your user is a bit lazy and doesn't want to fill out each address field individually. It can be tedious. So here you can copy-paste an address and format it automatically. You will get different results depending on the provider and model you choose. You can compare them for fun, but also to tune what you want to achieve. It's up to you to select the model that suits you best, whether it's from OpenAI, which offers many models, or Ollama. It's also essential to craft an effective prompt, since it plays a significant role in this. But check the code, you will see there's nothing complicated. You can input poorly formatted addresses and the model will handle it. It extracts all the relevant elements from the text. For you users' productivity, it's, I think, a valuable feature. So to wrap up, we've covered a lot in this demonstration. We've seen how to use 4D AI Kit with a cloud provider like OpenAI, highly performant, highly efficient. We've also explored using a remote Ollama server to ensure data confidentiality, and we've seen how to search for fuzzy similarities in a database using vectors. So thank you, and I hope this inspires many ideas to you.
Thank you, Mathieu. Very, very interesting. As you can see, 4D 20R10 introduces vectors. So for today, we focused our demos on simple hands-on examples of vector search. But don't worry, Mathieu is preparing a dedicated AI webinar that will take things much further. The date will be announced very soon, so stay tuned and keep an eye on your inbox. So let's switch gears and talk about 4D Qodly Pro. Before unveiling what's new in 4D Qodly Pro, a quick reminder, if you missed the webinar with Thomas Maul, go check out the replay. Hundreds of attendees joined live, and the session really resonated with a wide range of customers. The questions and reactions were genuinely interesting. It's full of practical insights on how to bring modern, web-based form into your 4D desktop apps using Qodly Pro. Definitely worth watching. You'll find the link just in the chat. Now, let's zoom on what's new in 4D Qodly Pro R10. Just to highlight, since the demo will cover it all. HTTP handlers now come with a much simpler setup UI. The new Qodly namespace gives you access to title and the location object Qodly sources, so you can update browsers, tabs, and respond to URLs instantly. Also, on the UI side, the matrix component adds more control over selection behavior, and the date picker is easier to navigate with dynamic date control. You can also fully style the select box search bar with CSS, and users get automatic connection status message with no extra code. Let's see it all in action. Here's a quick demo with Mourad to walk you through the features we just covered quickly.
The purpose of this demo is to show you all the new features we have added to Qodly Pro, starting with HTTP handlers. So here in my classes, I have this utilities class and I have this function say hello that only returns a simple object saying hello world. And my HTTP handlers, the old UI, it used to be really hard to edit multiple HTTP handlers at once, and it had a lot of dead space. With this new one, it is more efficient and easier to edit your HTTP handlers. So let's put in utilities, and I have my say hello function, and I want to call it on hello, and I want to use get request. So I'm gonna do this trick where I try to preview it, and what I'm gonna do is hello. And as you can see, it works here. Next up on the list is the new matrix selection behavior. Now, if you select your matrix, you will see that you have multiple behaviors. We have select and scroll first, select and scroll current, and no select. So let's go and try it out. Select and scroll first. I'm gonna preview this, and every time I change the data, you'll see that it selects the first item all the time. And the next one is select and scroll current. With this one, if you have a selection at an entity, it always stays there. So let's go with root, and you see, I change the data and root always stays selected. And the third one is the default matrix selection, which it doesn't select anything unless you select it yourself. So I can change the data here, but it doesn't select anything. But if I select it on an index, the selection stays on that index, as you can see here. And next one on the list is a new namespace called Qodly. It has information about the location object and also has information about the title, and which you can change the title and have custom titles. Let's start with location. So let's create a new page here, an empty page, call it location, and take this location and drop it on a page so we can see what kind of information it gives us. So let's preview this. As you can see here, it will give me the URL query that has all the query params that I have, query source params that I have on my link, and also URL path. It will give you all the parts of the URL, so and an array. An anchor, it will give me information about my anchor. So if I put something like hello, you will see that the anchor is here. Usually it is only one. So, and I can also have multiple params like search or something like that. And also, if you can see, I have information about location and I have information about search, but search is empty. So let's just add something here. Okay, cool. So now let's use this. So I have this people page, right? And this people page, I have an on init that takes in the location URL query .search and searches for people. So here's the function. I take the search and I put it in a query and I order by first name. So I have that and I return people selection. All right, let's try it out. So it gives me all the people. So let's just say search and let's search for Rudd. And as you can see, it will give me what I searched for. Also, what we can do is we can set a custom title. As you can see here, we have a generic people that corresponds to the page name here, but we can customize also. So let's add a new event on the net and Qodly source. I want to change the title and I want to set the source and I want to set it to hello world. Let's save this. Let's get back here and recharge and you will see that I have hello world on the page title. Next up, what we have added is network connectivity activity indicator. So every time, so let's just say that I disconnect from my Wi-Fi, you will see it'll give me information here that like I have lost connectivity. And if you come here, I will have like a permanent banner saying that I have lost connection. But if I connect again, you will see that it comes back. Next up, what we have is date ranges. So I'll add a new page and drop in a text input. And here, I'm gonna have it as type date. What we have added is intervals. So I can add an interval and I'm gonna call it range. And I'm gonna say from Monday to Monday 15th. So this range is all what the user can choose from. So if I come here and click here, you will see that only this range is selectable by the user. Next up is the ability to customize the search item and the select box. So here I have this search box and you can see like we have added new classes so you can customize the search. So we have flexbox search, flexbox search input, and you can change the color of the icon. So if I preview this and go here, as you can see, you can customize everything about the search input. And also what we have added, let's get back here. We have this array here. As you can see, this array is scrambled and has like a lot of data, and it is hard to edit. What we can do is this is like you can click on this button and you can click you can edit every individual item of the array. And there you have it. That's all we have for this demo, showcasing all the new features we have with Qodly Pro.
Thank you, Mourad. Now move to what's new on development side. Let's start with something that usually causes headaches, the project dependencies. They can get messy fast, especially when your components rely on other components, which rely on even more components. With 4020 R10, that complexity is handled for you. Add your primary component, and 4D automatically loads everything it needs recursively. Sub-dependencies loaded automatically. Version rules checked. Conflicts resolved. You also get full visibility through the new interface, showing what's declared, what's inherited, and where it all comes from. So your dependency trees stays clean, even as your project grows. Now let's talk dynamic forms, because flexibility is the key. While the object that set data source for the command required rigid pointers as parameter, the new for the command object set data source formula and objects get data source formula allow you to bind any formula as a data source using simple expressions like form.attribute, entity attributes, or full object notation. This makes your UI faster to update without manual rewriting, and it also makes your forms more reusable, so you don't have to duplicate logic. And it allows dynamic behavior driven directly by your data or business rules. And yes, it works for list boxes too. Current item, selected items, and position. Everything is handled through formulas. Let's take a look on how it actually works. Vanessa will walk you through a quick demo of the new data source commands, so you can see just how dynamic and flexible your forms can become. Vanessa, it's up to you.
The new object set data source formula command allows developer to bind a formula as a data source for form objects. In addition, the listbox set property command can now be used to dynamically define expressions for key listbox properties, such as the current item, its position, or the list of the selected item. In this example, we'll be working with a person table, which includes the field first name, last name, job, and department. Her goal is to display this data in a list box and allow user to edit it using inputs field. Let's start by defining the data source of the list box. With object set data source formula, I can specify an expression that dynamically populates the list box. Then I use listbox set property to define the expression that returns the current item. Next, I create the listbox column. Nothing new here. I use the listbox insert column formula command to add a column along with its formula, and object set title to set the column header. Here. And finally, to allow editing of the selected data, I create input field with object duplicate command. And to link each field to the selected item, I use object set data source formula to define a formula as a data source for each field. And here's the result. With these new commands, you can fully leverage formula and object-oriented programming in your dynamic form. You get more flexibility, better maintainability, and cleaner code.
Yes, thank you, Vanessa. All right, let's shift focus to a huge part, which is entities in ORDA. Until now, if you needed default values when creating an entity, you often had to write a helper function like create new. But the problem is that you had to remember to use this helper function everywhere in your code when you created an entity. With 4020 R10, you can now define a constructor directly inside your entity, your data class. This constructor runs automatically whenever a new entity is created. So whether it's a timestamp or the current users or default values, it all happens behind the scenes. Just call ds.products.new and you're done. No more custom create new or other functions workarounds. The logic lives in one place and runs automatically. You also avoid mistakes or inconsistencies across different parts of your app. Data integrity is ensured across context. And best of all, your initialization logic is centralized and easy to maintain, making your code base simpler, safer, and more predictable. Meaning the constructor runs automatically in every creation path. When you create an entity manually with ds.product.new, when you import data using the from collection function, when someone creates a new record in the Data Explorer, or even when a client app creates data remotely through the REST server. I know you would rather watch demos than listen to me talk, so let's join Marie-Sophie as she meets this new constructor.
Welcome to this demo. I am going to show you how to implement an ORDA entity constructor. ORDA provides fully object-oriented access to data. In ORDA, everything is an object, starting with the data store itself, as well as the data classes, the tables. With ORDA, data is not managed through records, but through entity objects, which are instances of a given data class. The concept of a constructor is now available for these entity objects. So let's start working with this products table. On this form, we can create a new product, and we can see that the creation date and the comment attributes are pre-assigned. Let's look at the implementation. This is handled in the code like this. The new product entity is instantiated and after the attributes are initialized. So when I create a product, we can verify that this implementation works. But this type of default initialization can be factored in the constructor of the product's entity class. So I comment this code, I also copy it, and I am opening now the product's entity class, and I implement the constructor. The syntax is the same as for a regular class. I passed the code. The this keyword refers to the current instance, so to the current entity. So the stamp and the comment attributes are initialized now in the constructor. Let's test again the form. So it works. I can create my new product. We can also check the data in the Data Explorer. So all works properly. But the constructor does not apply only when calling the new function to instantiate a new entity. It applies to any creation of a new entity on the server, regardless of how it is created. Now let's try sending data to the REST server to create a new products entity with the API method update. So I send this request, and we can verify that the attributes have been correctly initialized with the default values. And the last check, what happens if we send to the server an attribute that is initialized by the constructor? I had here the comment attribute because it is set by the constructor. And we are going to check what happens in this case. I send the request, and in the Data Explorer we verify that the constructor has been properly executed, but the value sent by the client for the command attribute has been kept. So the implementation of the constructor allows for even more object-oriented entity management. Attribute value initialization can be centralized in a single place, which optimizes the code. Thank you for attending.
Thank you, Marie-Sophie. Let's dive into a new addition now, ORDA events that can basically be compared to the classic triggers and tables. Starting with 4020 R10, we are opening a new chapter. In-memory data events, for example, tied to users' interactions with the form. And the first of these events is the touchsheet event. The ORDA abstraction layer can now react to any change made to data in memory on an entity. So what does this unlock? Real-time validation and formatting before saving. You can clean, validate, or format input as soon as it's touched, without waiting for the form to be submitted. Centralized logic. Instead of scattering logic across multiple form events, you can now centralize in the data class. Indexed query optimization. You can keep Scholar attributes updated as soon as input is touched, making them queryable with index support instead of falling back to slower formula-based evaluation and so on. This last point is especially useful in cases where queries involve comparison between multiple attributes, which can always use indexes. With the touch event, you can pre-compute and store the result in a Scholar field, then query it efficiently. For technical details, check the doc linked in the chat. Thank you, Basma. And yes, you can take it a step further. You can now define touch events for specific attributes only. This gives you precise control over what logic runs when users interact with the specific attributes, and shown in this example. And this is just the beginning. More in-memory events are planned for future versions of 40, giving you even more control. So now that you've seen what the touch event brings to the table, let's jump into a real-world demo with Marie-Sophie so you can see it in action.
Welcome to this demo. I am going to show you how, thanks to ORDA, we can detect changes in attribute values on entities that are in memory. Let's take the example of modifying a product. In general, the user flow will load the product to be modified into memory, present it to the user who will interact with the data through an interface. Then the user will click a Save button and the data will be persisted in the database. ORDA provides the concept of events on data held in memory. The first available event is the touched event, which makes it possible to detect whether a given attribute has changed or whether any attribute of an entity has changed. So to go on, let's start working with a products table that has the attributes cost price and retail price. We have a computed attribute, the margin computed attribute, which has been implemented to determine whether a margin is made of the product or not. If I run this form, we have 3 products. We modify here 1, and we can verify that the computed attribute is updated. So this works properly, but if we look at the implementation of the query for the margin computed attribute, we see that this attribute depends on the value of two attributes relative to each other, and therefore the query is resolved by an eval, so by a formula, which makes it impossible to use an index when we query this margin attribute. So this is a good example for using here the touched event. So to start, I now create a real attribute on the products data class. I am now creating the margin down attribute. It is also a Boolean, and this attribute must be updated each time either the cost price or the retail price changes, and the touched event allows us to detect this. So in the products entity class, I implement the touched event. An event is implemented as a function, and we use for this the event keyword. So I implement this event for the attribute cost price. The rule is this one. If the retail price is greater than the cost price, then the margin down attribute is set to true, else it is set to false. And I also implement a touched event for the other attribute. So for the retail price attribute, I just change the attribute name. And on the form, I add a colon in my list box. I duplicate the colon to display the margin down attribute. And I change here the attribute name. So let's test that. I select a product and I modify here the retail price, and we can verify that the margin down attribute is immediately updated in memory. So we can run a query, an optimized query on this attribute, which can be indexed. And we can check also the data in the Data Explorer like this. Now, if I modify the product via the REST server, so I use the primary key of this product to send a request to update it. So I change the retail price of this product to have the margin down attribute changed. And I send the request. If I refresh the data here, we can verify that the touched event has also been detected here by the server. The implementation of this event allows data to be prepared and kept consistent before the save action with factorized code. It is intended to run light code, so code not consuming too many resources, since this event can be triggered at any time when an attribute changes. Thank you for attending.
Yes, thank you, Marie-Sophie. So if you're wondering how the touched event behaves across different architecture like client server, REST, or remote data stores, check out the blog post linked in the chat so for a full deep dive into its network's behavior. So yes, I'm done. Mathieu, show us what's next.
All right, let's continue this morning's marathon and look at something new on the network improvements side. With 4D20R10, the TCP Connection Class introduces a new .connection property. This gives you full control over how long 4D should wait when trying to establish a connection. If the timeout is reached, the connection is aborted. No more hanging or freezing. That brings 3 key benefits right away. You can define latency threshold to keep your app responsive, can automatically abort longer stalled requests, and you can recover quickly from network errors instead of infinite waiting. It's a small line of code, but it's a big step forward for performance and user experience. Now let's talk about something that completes the network picture in 4D. With 4D 20R10, we've added the new UDPSocket class, building on TCP connection from R8 and TCP listener from R9. And this new class gives you full support for UDP communications in 4D, both client and server. Why should you use UDP? Because it's lightweight and connectionless. There's no persistent link, no delivery guarantees. It's designed for send and forget scenarios. So that makes it ideal for use cases like IoT devices, real-time monitoring, or broadcasting updates to many clients at once, quickly and efficiently. You also get support for asynchronous and preemptive operations and a modern replacement for the old Internet Commands plugin. And of course, it's all native to 4D. Let's see how it works in practice, starting with the UDP client. Building a UDP client is incredibly simple. You just need a UDP socket object and a destination IP and port. To send a message, just use the send function of the UDPSocket class. And that's it. Your own UDP client class is ready to use. You can now send messages to a UDP server. No response expected, no connection needed. It's a true fire and forget approach. Speaking of UDP server, to build a UDP server, you will just use the very same native UDPSocket class plus a listening port. When a message comes in, your onData callback is triggered automatically, letting you process the data right away. Everything runs asynchronously and preemptively, so your app stays responsive, and you can even run your server in a worker, keeping it fully isolated and always listening. Okay, let's move on to another key improvement in 4D 20R10, the stricter class-based typing for objects. Previously, 4D only checked whether something was an object, but that wasn't enough to prevent logic errors. So you could still assign a completely unrelated object like a shelter to a variable expecting an animal and only find it out later. Now 4D verifies the actual class type at compile time, but also while typing in the editor. So if you try to assign the wrong type, you get an immediate error. No more guessing, no more silent bugs. This gives you 2 big benefits: smarter auto-completion based on class type and stricter compile time checks to catch mistakes early. It's not just for variables or functions. This also applies directly to your data model. In the structure editor, you can now assign a specific class to an object field. Just for example, you can link a field to the 4D.vector class. I don't know, for doing AI, for example. That means 4D doesn't just see it as an object. It knows it's a vector with all the associated methods and properties. From design time to runtime, everything stays consistent and type safe. And inside the editor, you get instant auto-completion based on the declared class. Let's continue. I know it's a lot this morning, but let's continue talk about UUIDs. Up until now, 4D generated UUIDs using system functions, typically version 4. These are completely random which is fine for uniqueness, but not great if you care about sorting or tracking when something was created. With 4020 R10, this changes. UUIDs are now generated internally, and you can opt for version 7, which includes a timestamp prefix. That means your UUIDs are no longer just random. They're still random, but they are chronologically sortable. Why does that matter? Because now new records naturally appear in order. No need to manually add timestamp fields or sort logic. It's especially useful for things like logs, creation tracking, or any kind of ordered list. And since the timestamp goes down to microseconds, you get more precision than the traditional timestamp command. By default, 4D still uses version 4 UUIDs. And to enable sorting, switch to version 7, either in the settings or with the generate UUID command. That's it. So we can see all of this with a demo. The last one this morning. I know you will miss us. Let's go. Thank you, Damien.
Hi everyone, this demo will show you how 4D handles version 7 UUIDs. As a reminder, UUIDs are 128-bit integers usually represented in hexadecimal format. Until now, 4D used system functions to generate UUIDs, which resulted in version 4 UUIDs. With 4D 20R10, 4D now generates UUIDs internally to control the version being produced. If I click this button, I'll generate version 4 UUIDs along with a creation sequence. When I click on an item, I can see the UUID version. Version 4 UUIDs are almost entirely random, so sorting them is meaningless. As you can see here, the creation sequence is not respected. On the other hand, version 7 UUIDs are prefixed with a timestamp. If I generate UUIDs, I can see that they can be sorted in a current way. How did I generate these two versions of UUIDs? It's very simple. I click the trace button to view the code. For version 4, it's the same generate UUID command you're already using. For version 7, you simply pass the value 7 to the generate UUID command. It's very straightforward and ensures the longevity of your developments. On the database side, version 4 is still used by default for automatic UUID fields, as you can see here after generating 10 records with their sequence. If I want to switch to version 7, I just open the structure settings and select the version to use. Then I simply restart my project. I generate new UUIDs. They are now version 7. Simple, isn't it? I hope this demo was helpful. See you soon.
Thank you, Damien. And we will continue with 4D NetKit and a new useful enhancement, which is calendar management. You can now manage events using Google Calendar or Microsoft 365 APIs right from your 4D code. First, so you can create events programmatically. Just set your event details and use the .createEvent function. It works the same for both APIs. Second, you can update events, like adding or removing attendees without having to cancel or recreate it. Use the update event function, and the changes sync instantly. And third, you can delete events using the delete event function. What a surprise. It's useful for cleanup and cancellations. All of this helps you keep calendars accurate and your team aligned without leaving 4D. Let's start with the last section of this morning's presentation, and it's the deployment news. So we will talk about embedding deployment licenses automatically. You can now embed deployment licenses automatically, so your builds are portable, version control, and ready to use across machines. No more editing license path or setting things up manually. Let's walk through the options you have. The first one is the default, no licenses included. That means users will have to register a license when they launch the app. It works fine if you're deploying manually or leaving licenses to the end user. Next, you get the evaluation option. It's great for demos, build, or quick testing, no license needed, just build and run. Then comes automatic embedding. Here, 4D checks your machine for valid deployment licenses and includes them in the app. You don't need to specify anything manually, and nothing is hard-coded into the build settings. That means your build file is cleaner and easy to reuse or share across your teams. And finally, if you prefer full control, you can manually define which licenses to embed. This works just like before, and it's useful if you need to match a specific setup or stick to a non-list. Before saying goodbye, we announce you of an upcoming webinar on September 24th, which will be hosted by Vanessa and will cover the topic of CSS for the desktop forms. So you will learn how to implement them to design user interfaces more beautiful than ever. All right, so don't miss this webinar about 4D desktop forms and CSS. And this is it. As usual, you can find more details in our blog. All the features you saw today, including the demos, are available there. It's a great source of information if you want to dive deeper. And I'm sorry, it's time to say goodbye. And thank you for attending. So we hope you will love and use this for the 20 R10 feature release. Right.
Thank you. Bye-bye, everyone.